So this is chapter 15.6, rational equations. So we learned about complex fractions. We learned about rational expressions. Now finally we're going to take those concepts and turn them into equations, meaning we're going to be solving for the variable this time, not just simplifying, we're going to be solving. So the concepts we're going to look at is introducing rational equations, solving rational equations, and then solving formulas involving rational equations. This third concept here is the same as solving literal equations. And what a literal equation is an equation filled with multiple variables. Just some extra knowledge. When you ever hear literal equations, that's the same as saying solving formulas using rational expressions. So concept 1, introducing rational equations. So we already talked about linear equations. A linear equation is y equals that ax plus b. Or in this case, they had ax plus b equals c. Same thing. Okay. Then we talked about quadratic equations. So the standard form for quadratic equations is ax squared plus bx plus c equals 0. So we already talked about these first two. Now we're mentioning rational equations. So this is an equation with one or more rational expressions. So for example, a over x plus b over c is equal to d over e. So a fraction plus another fraction will give us a fraction. In this case, the only variable is x. That a, b, c, d, e are old numbers. Okay? A, B, C, D, E are old numbers. And x is our variable. So in this case, we would be solving for x, getting x by itself. Okay. So knowing that, looking at number 1, we have a rational equation in terms of what variable? What's the only variable we see here? Y. That tells us that we need to get y by itself because we are solving for y. So looking at only the left side, just this left side here, we have two fractions that are being added together. In order to do that, we need to get a common denominator. And what would be the common denominator between 2 and 4? 4. So do we need to do anything to this fraction? No. What do we need to do to this fraction? Multiply by 2. So I have 2 on the top and 2 on the bottom. So if I simplify this, I have 2 times y, which is 2y, over 2 times 2, which is 4, and I bring down the other fraction in the rest of the equation. Now I have something with a common denominator. So what can I do to the numerators? Add them. So I have 2y plus y, which gives me 3y. Remember, it's only y squared if we do y times y. So this is y plus y, so that's why we got 3y. Okay, over 4 is equal to 6. Okay, there's multiple ways we could go about solving from this step. We could get a common denominator for both sides, right? Subtract that 6 over, make it equal to 0. That's one method. Or what I find the easiest is to turn the other side into a fraction. So how would 6 become a fraction? 6 over 1. And then once we have it as a fraction, so a fraction equal to another fraction, we can cross multiply. So that meaning I'm multiplying that 3y times 1 and that 4 times 6. Okay. So doing this, it's going to turn our equation from a rational equation to a linear equation. So 3y times 1, so let me just write out each step, is equal to 4 times 6. So that means we have 3y is equal to 24. So notice how we now have a linear equation. What are we doing now to get y by itself? Divide by 3, so that tells us y is what? Y is 8.
Now, on something like this, going to where you started the cross multiplication, could we not just see that we're dividing by 4 and we want to essentially reverse that, so we just multiply both sides by 4?
Correct. You could do that. Like I said, there's so many ways, but yeah, that would be a way too. You can multiply both sides by 4, and then you would still end up here at that 3y equals 24. Okay. So one last thing we need to do, since we are dealing with rational equations, is we need to check if we have our variable in the original problem on the denominator. So we're looking at the original problem here. Are our variables on the denominators? No. So that means we don't need to do any extra step. The reason we're checking if it's on the denominator is because, let's say on the denominator we had, let's say y minus 8, right? Let's say instead of that 4, it was y minus 8. If we plug in that answer of 8, what would we get on the denominator? A 0. And can we divide by 0? No. So that means once we check to see if that variable, that answer is on the denominator, if we ever get 0, that means our answer is going to be what? Undefined. Okay, so here we don't need to check. So you check by plugging in your answer only if the variable is in the denominator. So since in this problem our variable was only in the numerators, that means we stop, and this y equals 8 is our answer no matter what. Okay, any questions about that last part that I wrote in red? Okay. We're going to see an example of that in 2, because notice in 2, not only do we have a variable in the numerator, we also have the variables in the denominators. So that means once we find our answer, we're going to have to plug in our answer into the original problem to make sure that this 2z and this c does not turn to 0. Okay. But before we do that, we are going to look at only the left side. So this side here, and we're going to get a common denominator. So looking at the denominators 2 and 2z, what would be the common denominator? 2z. So that means the only thing we would have to do to that first fraction is multiply top and bottom by z. Okay. When we do that, we have z times z, which is z squared, and 2 times z, 2z, that common denominator we were trying to get, and I'm now bringing the rest of my equation down. Okay. Still looking at the left side, now that I have a common denominator, I can combine my numerators. So I have z squared minus 1 over 2z is equal to 12 over z. Is there anything I can simplify before I start cross multiplying?
Yes.
Which part?
The numerator of the left side.
Good. The numerator here, what does this look like? A perfect square. So what would be my factors? Good. Z plus 1, z minus 1. Okay. Okay, so looking at this, it looks like we can't cancel anything on that first diagonal where we just simplified the z squared minus 1. But what about on the other diagonal? What could we simplify on this diagonal? The 12 and 2. So this would become a 6 and this would become a 1. Okay, I simplified everything. So now, since I have a fraction equal to another fraction, I'm going to do what? Cross multiply. So that means I have z times z plus 1 times z minus 1, that's that pink diagonal, is equal to 6 times z. So 6z. Okay. Now looking at this problem here, what could we cancel on both sides? What do both sides have in common? A z, because they're all being multiplied, right? And since they're all being multiplied, we're able to do this. So I'm going to cancel the z on either side. So that means I am left with z plus 1, z minus 1 is equal to 6. What type of equation does this look like? It's no longer rational. It's not linear. Quadratic. That's the only other one we learned about, quadratic. So since this is quadratic, that means we need to have it equal to 0. But before I do that, I'm going to have to FOIL these back in. Or, if I remember from above, this z plus 1 times z minus 1 is the same as writing what? Z squared minus 1. So I'm going to take this and say this is z squared minus 1 equals 6. I have to have it equal to 0. So what am I going to do with that 6? Good. So I'm going to subtract the 6. So I have z squared minus 7 is equal to 0. Okay. Is this still a perfect square? No, so that means instead of factoring this as a perfect square, we have to factor using the what method? The AC method. Meaning this is the same as saying z squared plus 0z, because there's no b value, minus 7 equals 0. So using the AC method, what is my a times c? Good. 1 times negative 7, which is negative 7, and my b value is 0. So from here, I need two numbers that multiply to negative 7 but add to 0. Do those numbers exist? Because what are the only factors of 7? 1 and 7. where one of them is negative. If we add any of those together, will we ever get 0? So that tells us that this z squared minus 7 equals 0 is not factorable, meaning we're going to get an answer that is what? No solution or undefined? Good, undefined. Why is it not no solution? As of this point right now, because we haven't talked about using quadratic formula or anything like that. So we say this is undefined because we, at this point, haven't learned about the other ways to solve a quadratic function. We only learned about factoring. If we were able to use the quadratic formula and get an answer, and that answer still didn't work, then it would be no solution. But since we never learned about that, we can only just say undefined. Or if you just write not factorable, that's a good enough answer too. Okay, so we went through this whole process. After we cross-multiplied, we noticed that this was a quadratic function. We put it in standard form. We tried to factor, but we couldn't, so our answer is not factorable / undefined.
There was another problem that we did in another section where I believe the answer we were working with was not factorable, but in that sense there was no restricted values.
Yes.
How is that different from this?
There's no restricted values. So the only reason I'm saying that this is not factorable undefined is just because we haven't talked about the concept of quadratic formula yet. So if we would have already talked about quadratic formula, we could use the quadratic formula to solve this, and it would end up with probably a very small decimal or an imaginary number. We just don't know, since, again, I haven't covered it yet in this course. So then we would just label it as not factorable, undefined.
Like, so since we're kind of looking at, for lack of a better term, like for the most part, whole numbers or like solidified fractions, like if we aren't using decimals, we would just leave it like that.
Yeah.
Okay.
You could just say this step right here,
Gotcha.
not factorable, and that would be a good enough answer for me.
Okay.
I get where that undefined is confusing. So ignore that. Just put not factorable. Okay. What was that first concept? Okay. So in that first concept, we were just looking at those as examples. So we're doing the same thing here, and we are going to use method 2 like we did in the previous notes, and we're going to multiply everything by a common denominator. So right away, we're going to get rid of the fractions. So looking at number 3, we have the denominators x, 3, and 6. So we're using that method 2 from the last notes. So what would be the common denominator between x, 3, and 6? Good, 6x. So if the common denominator is going to be 6x, what are we multiplying that first fraction by? 6, because we want it to be 6x. What are we multiplying the second fraction by? 2x, because it only has that 3. And then what about the last fraction?
X.
Okay. that means if I was to rewrite this, I would have 6 times x plus 1 over 6x plus 2x over 6x plus 5x, equals over 6x. So just like in method 2 on the last notes, if we have all the same denominator, what can I do with those 6x's? Cancel. So I'm canceling out all the denominators. So now I have an equation that is not a fraction. So I have 6 times x plus 1 plus 2x equals 5x. Okay. I want to solve for x, so I need to make sure I have all of my x's on one side. But before I do that, what can I do with that 6? Distribute. So I have 6x plus 6 plus 2x equals 5x. Now what do I want to do if I want all my x's on the same side? Subtract 5x. So now I have 6x plus 2x minus 5x plus 6 equals 0. So combining my like terms of all my x's, how many x's do I have? 3x plus 6 equals 0. I need to solve for x, so what am I going to do with the 6? Subtract 6. And I have 3x equals negative 6, which means that my x is equal to what? Negative 2, because I'm dividing by that 3. Okay. However, remember I said if we have a variable in the denominator, so if we look at number 3, the only variable we have in the denominator is that first fraction. It was an x. If I plug in negative 2 into that denominator, would it give me 0? No, it would just give me negative 2. So that means my answer is that negative 2. If it gave me the 0, meaning I would have a fraction divided by 0, then it would be undefined. But since this x is there by itself, I would replace it with our answer of negative 2, and that would not give us 0. So that means our answer is x equals negative 2. We have to do that last mental check every time when our variable's in the denominator, because we have to see if our denominators will turn to 0 if we plug it back in. Okay, and that goes back to those restrictions we talked about in previous notes. Any questions on 3? So we're going to be using that method too for the rest of these problems. So looking at number 4, we first need to turn that 1 into a fraction. And so now we're looking at the denominators 1, a minus 2, and a minus 2. So what's the common denominator? A minus 2. And the only fraction that's changing here is which one? The first one. So a minus 2, a minus 2. So that means we have a minus 2 over a minus 2, and then everything else stays the same. So I'm just bringing down the rest of my equation. So now that I have the common denominators of a minus 2, what can I do with those denominators? Cancel. So I'm left with a minus 2 plus 3a equals 6. Now I'm just left with a linear equation, no longer any fractions. So I first need to combine like terms. So what do I have on the left side once I combine like terms? Good, 4a minus 2 is equal to 6. And then I need to get a by itself, so what am I doing? Good, add 2, so I get 4a is equal to 8. And then my last step, divide by 4, so I get A is equal to 2. Okay. Before I claim that as my answer, I have to check, were there any variables in my denominator?
Yes.
Yes. So if I plug in 2 into this A minus 2, will I get a 0?
Yes.
And can we divide by 0?
No.
So that means instead of A equals 2 as my answer, what's my answer?
Undefined.
Good. It's undefined. And I'm going to write why. Because when I plug in 2, we get a 0 on the denominator. So my answer is no longer that A equals 2, because based on the restriction of the denominator A minus 2, when I plug in that 2, I get 0, and that's not possible. So my answer is undefined. So for rational equations, it's always best to just double check, even if you're just doing a mental check. If I plug in my answer, will I ever get a 0 on the denominator? Okay. Any questions so far? Okay, now we have number 5. So I'm looking at all my denominators. And I need to get a common denominator. But notice how my first denominator is in terms of a quadratic equation. So if I have a quadratic equation in one of my denominators, that should tell us right away that we need to do what? That we need to factor. So looking at this quadratic equation, which method are we going to factor by? The AC method. So our A times C is what? And our B value is -7. So we need two numbers that multiply to 12 but add to -7. Good. -3 times -4 gives us a +12. And if we add them together, we get -7. So that means we plug these in. T squared minus 3t minus 4t plus 12. And now we do what type of factoring?
Grouping.
Factor by grouping. So what are we going to take out of the first parenthesis? A t, so we're left with t minus 3. And what about the second parenthesis? Because we want them to match. -4, so we're left with t minus 3. So we have the factors t minus 4 and t minus 3. Okay. So that means instead of this original one here, we could write t minus 4, t minus 3. So knowing that that's the factors of that quadratic equation, what would be the common denominator between all three fractions? Good. T minus 4 times t minus 3. So are we doing anything to that first fraction? Nope, because they already have both. What about that second fraction? What is it missing? Good. So I'm going to multiply by t minus 4. Top and bottom. What about that last fraction? T minus 3, because it's missing that t minus 3 in the denominator. Okay. So let's see. Rewriting here. I'm now rewriting my equation where everything has a common denominator. So I have 6 over t minus 4 times t minus 3 plus 2t times t minus 4 over t minus 4 t minus 3 equals 3t times t minus 3 over t minus 4 t minus 3. Okay. Now that I have all the same denominator, what can I do with them? Cancel, so I'm only left with the numerators. And I am going to bring that down here so I have more room. So I have 6 plus 2t times t minus 4 equals 3t times t minus 3. Because my denominators are now gone, I'm just left with all the numerators. Okay. What do I need to do first before I combine like terms? Distribute this 2t and distribute what? The 3t. So I have 6 plus 2t squared, because 2t times t is 2t squared, minus 8t is equal to 3t squared minus 9t. Having the t squareds in there tell us what? What type of equation is this going to end up being? Quadratic. So that means once we simplify this and get everything equal to 0, we're going to have to factor again. So we want our right side equal to 0. So what are we going to do? We want this side equal to 0.
Subtract 3t squared and add 9t.
Good. We're going to subtract the 3t squared over, and then we're going to add the 9t over. So that means I have 2t squared minus 3t squared. What am I left with if I subtract those?
Negative t squared plus t plus 6.
Negative t squared, so we're just looking at this part first. And then now I'm combining my like terms of t, so what's negative 8t plus 9t? Just t. And then I bring down that plus 6 equals 0. Okay? Before I start to factor this, do I ever want a negative in the front? No, so what am I going to do to all the signs to get rid of that negative? Good, do the opposite. So instead of negative t squared, I have t squared. Instead of positive t, I have negative t. Instead of positive 6, I have negative 6. Okay, so I'm left with a quadratic equation that I'm going to factor using what method? AC, good. So A times C in this case is what? Yep, 1 times negative 6, which is negative 6. And what's our B? Negative 1. So what two factors multiply to negative 6 but add to negative 1? Negative 3 and 2, correct. Negative 3 times 2 gives us negative 6. If we add them together, we get negative 1. So these are our factors. So that means I have t squared minus 3t plus 2t minus 6. So now I'm going to factor by grouping. What can I take out of the first factor, the first parenthesis? A t, so I'm left with t minus 3. And what about the second one? 2, so I'm left with t minus 3. So that means I have t plus 2 and t minus 3 equals 0. So what am I going to do to each factor to get my answers? equal to 0. So if I have t plus 2 equals 0, that means our t is going to be what? -2. And if I have t minus 3 equals 0, that means my t is going to be +3. Are these my answers?
No.
No, what do I need to check?
Plug them into the denominators.
The denominators. Okay, so since we know that we had the denominator t minus 4 times t minus 3 on that first one up here, and I'm looking at this one up here, and they're similar to these ones, I'm only going to check these two. So t minus 3 and t minus 4. Out of both our answers, which one, if we plug it in, is going to give us 0?
3.
The 3, right? Because if we plug in 3 for t, we get 3 minus 3, which is 0. So since it gives us a 0 on the denominator, can 3 be an answer? No, meaning our only answer can be what? -2. So this one had a lot of different steps. We had to factor twice. And then once we got our two answers, we had to plug both in to make sure we wouldn't get a 0. So that we were left with t equals -2 as our only answer. Any questions on 5? Okay. Let's look at 6. Okay, so again, we're using that method 2 concept where we're going to get a common denominator for all the fractions. Before we do that, we're going to have to turn the 1 into what? Fraction. So now we have 1p and p squared. What would be the common denominator between those three? P squared. So that means we would have to multiply the first fraction by what? P squared. What about the second fraction? Just by p. What about the last fraction? Nothing, right? Because it already has the p squared. So then we have p squared over p squared minus 4p over p squared equals -3 over p squared. So now that we have the common denominator of p squared, what's going to happen to that? It's going to cancel. So that means we are left with p squared minus 4p equals -3. Since we have a p squared, this tells us it's going to be what type of equation? Quadratic. And for our quadratic equations, they have to be equal to 0. So what am I doing to that -3? Adding it over. So I have p squared minus 4p plus 3 equals 0. I have a quadratic equation, so I know I need to factor. So what method are we factoring by? The AC method. And so what is my A times C? Good, 3. And what is my B? So what's two numbers that multiply to 3 but add to -4? Good, -3 and -1. So I have p squared minus 3p minus p plus 3 is equal to 0. So what method am I using to factor? Grouping. What can I take out of p squared minus 3p? P. So I'm left with p minus 3. And what can I take out of -p plus 3? -1. So I'm left with p minus 3. So that means I have p minus 1 times p minus 3 is equal to 0. So now that I have my two factors, what am I going to do to each one?
Equal to 0.
Equal to 0. So if I have p minus 1 equals 0, what's my first answer? Positive 1. And if I have p minus 3 equals 0, what's my second answer? Positive 3, because it's adding that 3 over. So p equals 3. Okay, are these my answers, or do we need to check something? We need to check. So we go back to the original problem. And in the original problem, we had a p and then a p squared. Both of those in the denominator. If I plug in a 1 or a 3 into either of those, will I ever get a 0? No, I won't ever get a 0. So that means that p equals 1 and p equals 3 are both my answer. So if I plug in 1, I would get a 1 and a 1 squared, which is 1. If I plug in a 3, I would get a 3 or a 3 squared, which is 9, which again are not 0. So these are both my answer. So we can end up having no answers as an undefined, 1 answer, or 2 answers. Okay. Okay, now let's look at 2 applications. So our word problems. So just like before, we're going to have to take these word problems, turn them into the equations, and then solve. So since we're dealing with rational equations, we know we're going to have some fractions in there. So let's look at number 7. It says 10 times the reciprocal of a number is added to 4. The result is equal to the quotient of 22 and the number. Find the number. So first, we're going to have to label the number as a variable because we don't know what it is. So what variable should we assign to the number? X. So we're going to say x equals number. The first sentence here tells us the first side, the left side of the equal sign. So it says 10 times the reciprocal of a number. Okay, so reciprocal of a number, which is x, would be written as what? What's the reciprocal of x? 1 over x, because reciprocal means we flip it. So reciprocal of x is 1 over x. And then 10 times that. So how would we write 10 times 1 over x? Good, we just do 10 times 1 over x. And then it says it's added to 4. So we're going to write plus 4. So that's that first part. The second sentence tells us the other side of our equal sign. So equals. It says the result is equal to the quotient of 22 and the number. Quotient means what? Division. But it can also mean we write it as a fraction. Okay? So division or fraction. So it's saying the fraction of 22 and x. How would we write that? (22 over x). Okay. So now we have our equation. We have 10 times the reciprocal of x, so 10 times 1 over x, plus 4 is equal to the quotient of 22 and the number, so 22 over x. Okay. So in order to solve x to see what the number is, we're going to have to first simplify the left side. So what's another way that we can write 10 times 1 over x? 10 over x. plus 4 is equal to 22 over x. We can turn that 4 into a fraction by writing it over what? 1. So now looking at each of our denominators, what is the common denominator? X. So do we need to do anything to that first fraction? Nope. What about the second fraction? By x. What about that last fraction? Nope. So we are left with 10 over x plus 4x over x equals 22 over x. We now have a common denominator of all x's, so what can we do? Cancel. So we are left with 10 plus 4x equals 22. So a linear equation where we need to get x by itself. So what are we going to do first? Subtract 10. So we get 4x is equal to 12. And then what's our last step? Divide by 4, and we get x is equal to 3. Okay. We still got to go check if we have any variables in our denominator. Do we have any variables in our original denominator? If we plug 3 into that variable, will we get 0? No, so that means x equals 3 is our answer. Okay. Since this is a word problem, we have to write our answer as a what? Sentence. So the question here was find the number, so we would say the number is 3. Any questions on 7, how we turned it into the word problem into a mathematical equation, how we solved? Okay. Let's look at number 8. So same type of problem because it's telling us to find a number. So last time we labeled the number as x, so x equals the number. And the problem states the quotient of 10 in a number is 2 less than 4 times the reciprocal of the number. So in this case, it gives us both sides of the equation in one sentence. And we know that because what word separates our two sides? Is. So that means we have one side of the equation and then the other side of the equation. So the first side says the quotient of 10 and a number. How would we write that? 10 over x, because we know quotient means divide or fraction. Okay, so that is the first side. Then it says 2 less than. So anytime we see less than, where is that number going to go? The front or the back? The back. So this is going to have a -2 at the end. Then it says 4 times the reciprocal of the number. How do we write reciprocal of the number? 1 over x. So 4 times that would be written as 4 over x. All right, because 4 times this, and then that -2. So that means we have both sides of our equation now, and we want them to have all a common denominator. So that means we need to turn that -2 into a what? To a fraction. So I have 10 over x is equal to 4 over x minus 2 over 1. I need to get a common denominator, and what would that be? It would be x. That means the only fraction changing here is which fraction? 1, 2, or 3? That last one, and I'm going to multiply it both by x. So that means I now have 10 over x is equal to 4 over x minus 2x over x. Since I now have a common denominator, what can happen to those x's? Cancel. Remember, we're doing this because we want to get rid of the fractions. So now I have 10 is equal to 4 minus 2x. This is what type of equation? Linear, because we don't see any x squareds. So I need to get x by itself by doing what first? Subtract 4. So I get 6 is equal to negative 2x. And what would be my last step? Divide by negative 2. And I get x is equal to negative 3. Okay. So checking that negative 3 in my original equation, will I ever get a 0 in the denominator? No, I would get a negative 3 in the denominator, but not a 0. So that means that negative 3 is my answer. But since this is a word problem, my answer has to be written as a sentence. So what's my sentence? Good. The number is negative 3. That's my answer. Okay, so the important part here for these word problems is to remember that quotient means fraction. Reciprocal means we flip it. And if you ever see less than or more than, it goes to the back of the problem. Okay, so that finished up the concept of solving rational equations. Now we're going to look at the last concept, which is solving formulas involving rational expressions. And remember, I said this is another way to say literal equations. So it's an equation filled with a bunch of different variables, and the problem is asking us to solve for one of them. So for example, in number 9, we have the formula F equals MA over K. That's our formula. Our formula is already solved for F. But what does it want us to solve for in number 9? K. So we need to get K by itself. So I have F equals MA over K. I need to get K by itself. So what do I need to do first to, let's say, the F? What could we do to the F? Put it into a fraction, so F over 1. And now that we have a fraction equal to a fraction, what can we do? Or we can cross multiply. So if I cross multiply, I'm left with F times K, so FK is equal to 1 times MA, so MA. What variable am I solving for? K. So that means I need to get rid of that F. How can I get rid of the F? Divide both sides by F. When I do that, the F's cancel here, and I am left with K is equal to MA over F. That's my answer. So here, we're not getting numerical answers. We're manipulating a formula and having it equal to a different letter, different variable. So that function there, f equals ma over k, it's the same as that k equals ma over f, except we have k by itself versus f. Do the same thing for 10. So here's my equation. H equals 2a over big B plus little b. What is it having us solve for? Yep, that little b. Okay, so rewriting this, I have H is equal to 2a over big B plus little b. Remember, it's always easiest to have a fraction equal to a fraction. So what do we need to do first? Good, so h over 1. And now that we have two fractions equal to each other, we can do what? Cross multiply. So that means I have h times big B plus little b is equal to 1 times 2a, so 2a. Okay. I want to get that little b by itself. So what can I do to the h? So I could choose to distribute, but notice how that does not help me get this b by itself. It's just putting an h in front of each one. Because I technically don't need the h on this side. So where could I move the h?
Divide it.
I could divide it and put it on this side because I don't need that h. So if we were dealing with an equation that had a bunch of numbers in it, right, we would FOIL that h value in. But in this case, we don't need it. So I'm going to divide both sides by h. So these h's cancel, and I'm left with b, big B plus little b is equal to 2a over h. I want little b by itself, so what am I going to do to the other b? Subtract it. So subtract b. And so I have little b is equal to 2a over h minus big B. This is my answer. So I went from h equals to 2a over big B plus little b, solved for little b, and got little b is equal to 2a over h minus big B. So again, I'm not changing these formulas, I'm manipulating them. I'm getting them solved for a different variable. Okay, let's look at this last one. We have our formula of y is equal to x minus z over x plus z. Instead of having it solved for y, it wants us to have it solved for z. So I'm going to rewrite my equation. Okay. What's my first step? Y is a fraction, so over 1. What's my next step? Cross multiply. So when I cross multiply, I have y times x plus z. So y times x plus z is equal to 1 times x minus c. So just x minus c. Okay. Notice that I have z's on both sides. So I'm going to have to end up moving a z over so they're all on the same side. So knowing that, what should we do next? So remember last time how we got rid of that h that was there, so now that's a y. If we divide both sides by y, does that do anything for us on this side? No, because we'll still have that z there. So in this case, we should take y and do what? Distribute. So I have yx plus yz is equal to x minus z. Okay. I still need all the z's to one side. So which side do we want to move our z's to? Left or right? Okay, we can move it to the right, so that means we're moving that yz over because it has a z in it. So I had yx equals x minus z minus yz. So on that right side, we have two of our z's, but do we need our x over there? No, so I'm going to move my x over. And I get yx minus x is equal to negative z minus yz. Okay. What could we factor out the left side? What could we factor out from the left side? An x. So if we factor out an x, we're left with y minus 1. What could we factor out the other side?
Negative z.
Okay, we could factor out a negative z. So when we do this, we're left with 1 plus y. You see what I'm trying to do here? What am I trying to cancel out? That y minus 1.
So in this one then, you would want to just factor out a z then,
Correct.
instead of a negative z.
Correct. So we could factor out that negative z, but that does nothing for us. So let's just factor out a z. And we're left with negative 1 minus y. Okay, so we're getting closer here. What could we factor out of this negative 1 minus y? Because y minus 1 is not the same as negative 1 minus y.
Also the same thing.
So we could factor out a negative 1. So we're trying to keep everything separate here because we just want z by itself. Okay, because remember, this is not the same as this, because this is the same as saying negative y minus 1, which is not the same. Okay, so it looks like we aren't able to cancel these, okay, because it looks like we can't get them to be the same. However, notice that we now have z completely by itself, because it's all being separated by multiplication. So what can I do to these two parts to get z by itself? Divide. So I'm going to divide both sides by negative 1 times 1 plus y. So I'm left with z is equal to x y minus 1 over 1 plus y, and I can just move that negative here, that negative 1 here, I can just move it to the outside. So this becomes negative. And that's my answer. Because remember, my only goal here was to get z by itself. That's why it was important here when we found the GCF for this side that we didn't want to take out a negative z because we wanted a positive z to be by itself. Okay, you still could have took out that negative z and then eventually took out a negative 1 again. So there's lots of different ways that we could solve this. And again, 9, 10, 11 is all solving literal equations. So you're given an equation with a bunch of different variables, and you're asked to solve it for one specific variable.